Welcome back to Carneades.org. Today we are going to be continuing with Bayesian confirmation theory and the paradox of dogmatism as part of our series in Bayesian Epistemology. If you haven't checked out the rest of the videos in the Bayesian Epistemology series, this is going to be really confusing for you unless you have a really good foundation of Bayesian Epistemology. So I'd highly suggest you do that now. In this video, we're going to be looking at something called the simple principle of conditionalization. This is a principle that comes directly from our diachronic Dutch books that we looked at a couple videos ago. That's the main support for this principle, but what is the principle itself? Well, let's take a look. So, if you begin with initial degrees of belief, Pi, we're going to use that subscript I to represent initial degree and a subscript F to represent final degree of belief. And then you acquire new evidence, which is equivalent to certainty in E, some evidence. And your initial degree of belief in E was greater than 0. Then to remain rational, you must reassess your initial degrees of belief to final degrees of belief, PF, so that if S is some statement, PSF is equal to P of S given that E. That may not be very clear right now, but if you look back at the diachronic Dutch books that we looked at, it should be quite clear why you need to reassess your probabilities exactly based on the rules of conditionalization and Bayes' theorem. But if that's not clear, we're going to look at it in a different light than the Dutch books in the following example. So, imagine that you are someone in Renaissance Italy, and you're thinking about space. You're thinking about the world outside of this world. You think, statement H, the heavenly bodies are perfect spheres. You have a pretty high degree of belief in this. Most everyone you know believes it. That's what you've been taught your whole life. You have a 0.9 degree of belief in the statement, the heavenly bodies are perfect spheres. That's your initial degree of belief. There's another statement, some evidence, that we see mountains on the moon. You don't think this is terribly likely. You have a 0.15 degree of belief, initial degree of belief, in this piece of evidence. However, when you combine the two, saying that the heavenly bodies are spheres and there are mountains on the moon, you think that's really unlikely, because if something has mountains, it's probably not a perfect sphere. So you're going to assign that a pretty low probability. You're going to assign the degree of belief of P of E and H initial to 0.06. With that information, we can fill in a chart, and we can actually show what your final degree of belief in H should be if you are shown evidence E. We can show what your final degree of belief in the heavenly bodies being perfect spheres should be if you are shown that there are in fact mountains on the moon. We're going to set up this probability table again if you don't remember how these work. We have over here our hypothesis and the denial of our hypothesis and a total. And up top we have the evidence, the denial of the evidence, and another total. All of this is going to sum up to 1 because, as we remember from our laws of probability video, probabilities are going to be between 0 and 1 inclusive. And to stay in line with our Dutch book rules, our degrees of belief have to line up with probabilities. So, you have a 0.9 degree of belief in that claim that the heavenly bodies are perfect spheres. In order not to end up in a synchronic Dutch book, you have to have a 0.1 degree of belief in not H. If you have more or less than that, you will end up in a synchronic Dutch book. If you don't understand why, watch the video on Dutch book arguments. Similarly, you already have a 0.15 degree of belief in E, in the evidence, in the claim that there are mountains on the moon. Therefore, in order to stay rational with our Dutch book arguments, you have to have a 0.85 degree of belief in not E. Otherwise, you will also end up in a synchronic Dutch book. We've also been given that you have a 0.06 degree of belief in H and E. With this information, we can use, once again, the rules of synchronic Dutch books, assuming that you're rational, to find the rest of the probabilities. So, the probability of H and E and the probability of H and not E has to sum up to the total probability of H. So the probability of H and not E has to be 0.84. This seems to make sense. The most likely scenario that you think is out there is that the heavenly bodies are perfect spheres, and in fact there are no mountains on the moon. Similarly, we can sum going down our E column and find that 0.09 is the probability you're going to have to assign to not H and E. It makes sense that this is a greater probability than what you would assign to H and E, because you think if there are mountains on the moon, it's probably not the case that the heavenly bodies are perfect spheres. And you're left with a 0.01 degree of belief left over for not E and not H. With all of this information now, we can move forward and show what your final probabilities will need to be when you reassess them based on particular evidence. So imagine now that you look through a telescope and you in fact see mountains on the moon. You must reassess your initial probabilities in order to remain rational. So our simple principle of conditionalization tells us the final degree of belief we have to have in H must be equal to H conditional on E, based on Bayes' theorem. We state Bayes' theorem in the next line, which is just H conditional on E is equal to H and E over E. We're going to go ahead, plug our numbers in for that, and we'll find that the probability of H conditional on E, or your degree of belief in H conditional on E, is 0.4. This should make sense when we look back at our probability table as well, because we now have as our total 0.15, and as the one thing we're focusing on, 0.06. So now, instead of all of our hypotheses being summed out of the total of everything, so 0.9 out of 1, we have all the hypotheses we can see with E, which is just 0.06, out of all the totals we can see with just E, which is 0.15. That gives us 0.4. You'll notice that our degree of belief in the heavenly bodies being spheres has significantly decreased. It's gone from 0.9, almost certain that it's the case, to 0.4, convinced that it's probably not the case, or convinced that it's more likely that it's not the case than that it is the case. Therefore, we would say that E confirms not H and disconfirms H. But we're not going to get into confirmation and disconfirmation in this video. Watch the next video for that information. That was a simple principle of conditionalization. Next up is confirmation and disconfirmation, followed by entailment, Bayesian dogmatism, and the new paradox of dogmatism. Watch this video and more here at Carneades.org. Check out the SCP for more information on Bayesian Epistemology, and stay skeptical, everybody.